All right, geometry. So this is like one of those big days in your math lives. So for instance, like when the first time you like added, subtracted, multiplied, divided, the first time you dealt with fractions, the first time you might have used the quadratic formula, factored something, and now the first time you're using what's called trigonometry. So if you are, or you fancy yourself to be students can take math further, pre-calculus will go really in depth into trigonometry. So my hope is that when you get to pre-calc, if that's where you're going to go, you have some recollection of trig from this class. So we're going to talk about these things called trigonometric ratios, and we're going to use them to solve problems. So this main idea between trigonometry is you are relating sides of a right triangle to angles in a right triangle. And it really boils down to similarity. Okay, so before we even start the notes, I'm going to do a little activity in Desmos Geometry for you. Okay, so here's what I'm going to do. I'm going to open up Desmos Geometry. We're going to make two similar right triangles. So here's how I'm going to do it. Start with a line. I'm going to make a perpendicular from that line up here, right around here, and from this line around here. Okay, all right, so there's my two perpendiculars. Here's going to be my right angles, okay? And now I'm going to create two similar right triangles. This will be my smaller one. So there's that right triangle. And then I'll try to make one a little bit bigger, but the same shape, right? Similarity, same shape, different sizes. And now I'll hide everything else so that's not distracting to us. Okay, so why are these two right triangles similar? Well, first of all, they do have a right angle, which I created by doing the perpendicular. And then I'm going to measure this angle right here, 33 degrees, one of my favorite number probably, and 32. So I'm going to make this a little bit taller, and there's 33. So these two triangles are similar by angle similarity. So that means that their sides should be proportional, correct? Well, I'm going to introduce you to the first trigonometric ratio called sine. Sine. Now you're going to see that these trig ratios are defined ratios. I didn't make them up. Somebody else before me did. So sine is denoted as the opposite side over the hypotenuse. So in this triangle, 33 degrees is my angle that I care about. What side is opposite of 33 degrees? And hopefully you're thinking it's this side. I'm going to label it 1.99. And then which side is the hypotenuse of this right triangle? Well, hopefully you think it's this side. I'm going to go to Desmos Graphing Calculator, and I'm going to put those two numbers in a fraction, 1.99 divided by 3.67. So here's my graphing calculator, 1.99 divided by 3.67. And I got 0.54. So that's a number. Again, that's eventually going to be known as the sine of that angle, but for right now, it's a number, 0.54, a ratio, fraction. Okay. All right, let's do the same thing on this bigger right triangle. So here's 33. So this is the opposite side, 3.98. This is the hypotenuse, 7.25. I'm going to divide those, 3.98 divided by 7.25. So 3.98 divided by 7.25. And I get 0.548. So very, very close. And again, Desmos Geometry rounds, but as you can see, these two ratios are the same. And isn't that what it means to be proportional, right? Proportional sides have the same ratio. Okay. So what does this really mean? Well, these numbers, this ratio is attached to a 33-degree angle. I could have any right triangle with a 33-degree angle, and the sine of 33 degrees is going to be this ratio of 0.54. Now let me show you. Now before I do anything, this is a big announcement, right? We work with degrees. In the top right corner is the wrench. In the other world, radians is another way to measure degrees. We don't use radians in regular geometry, so I need you always to switch to degrees. Degrees. Okay. And now I'm going to type in SIN for sine of 33, because that's my angle. And watch what happens. You better be amazed. 0.54. So calculators now have the sine cosine, and tangent values of these angles and right triangles all stored. And all they are is they are ratios of sides in a right triangle. Okay, so again, what was the point? To show you that trigonometry is just similarity amongst right triangles. Be aware of that, remember that. So here's our big slide that we're going to talk about. So these are the trigonometric ratios. So as I said, the first one is called the sine. And again, you always do the sine of an angle. So in this case, we're focusing on A. So if A is our angle of focus, right, A, then we have to label the three sides based off of A. So if A is my angle, right there, then my three sides are opposite. That would be A here. Adjacent, that would be this side B here, and hypotenuse. Now we should always know that the hypotenuse is across from the right angle. The right angle points to the hypotenuse. Then you just have to memorize how to find the opposite side. So the opposite side is across the figure from the angle. I would say that 7 of you are going to struggle. 7 out of my 30 regular geometry will struggle identifying the three sides. That makes this section and this topic entirely impossible. So I need you really to focus on identifying opposite, hypotenuse, and adjacent. So to find the sine of an angle, it is the ratio of the opposite over the hypotenuse. That's sine. To find the cosine of an angle, it's going to be the adjacent over the hypotenuse. And to find the tangent of an angle, it's going to be the opposite over the adjacent. Now, we have shorthand for these. So if I was going to write the first equation in shorthand, it would be sine of A equals opposite over hypotenuse. Cosine of A would equal adjacent over hypotenuse. And the tangent of A equals the opposite over the adjacent. So you should try to remember these. Now, a way to try to remember those is this mnemonic, so, ka, toa. Some kids think this is very helpful, but the letters in so, ka, toa are the same letters in sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. So again, maybe this is helpful for you, okay? Now, what about the other acute angle? What about angle B? Well, if angle B was our angle of interest, which it can be, then that would mean that this would now be the opposite side. This would be the adjacent side, and this would be the hypotenuse, okay? So let me do one thing here with the A's. So to make it make sense here, so the opposite would be A over C hypotenuse, the adjacent would be B over C the hypotenuse, and then the opposite of adjacent would be A over B, right? So this is for my next part. So now what would the trig values or trig ratios for the angle B be? Well, now the sine of B would be equal to opposite still over hypotenuse, but now the opposite side to angle B is B and the hypotenuse is C. The cosine of B is still the adjacent over the hypotenuse, but now the adjacent side from angle B is A, hypotenuse is C. And then the tangent of B is going to still be the opposite over the adjacent, but those switch places. Now it's B over A. So my point to you is that the two complementary angles in the right triangle A and B, and again, they are complementary because if the right angle is 90, then A and B have to add up to 90, have sine and cosine values that are reversed. So the sine of A is the cosine of B, and the cosine of A is the sine of B. And then what word would you use to describe the tangent of A and B? I hope that you would use the word reciprocals. Because the adjacent and opposite sides switch places, depending on what angle you're looking at. See here, adjacent, opposite, opposite, adjacent. Then your tangent is going to flip upside down and it's going to become reciprocal. So I will show you many questions involving these three trig ratios. But again, the sooner you can memorize this, the better. Last thing is, remember that we are always in degrees, 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 degrees in this class for your angles, okay? So make sure that you click that wrench button in Desmos graphing calculator. If you're using a handheld calculator, make sure you're in degree mode. Now, when we do our problems, there are two types of problems. Sometimes you're looking for a side length, and sometimes you're looking for an angle measure. If you are looking for an angle, if you're trying to find the measure of an angle, you need to use inverse trig. That is these three notations. Sine of -1, cosine -1, tangent -1, inverse, sine, cosine, tangent. So say that I am looking for angle A. Well, if I'm given two of the three sides of a right triangle, I can find the value of angle A. So to find, so first of all, from A, this is the opposite side. Here's my right angle pointing to the hypotenuse. And this is the adjacent side. So if I were given the opposite and the hypotenuse, I would want to use inverse sine, because inverse sine is going to be still the opposite over the hypotenuse. So in this picture, to find the measure of angle A, I would take the inverse sine of A over C. So notice that angle A is by itself, and the ratio is with the inverse sine. Now, say I was given the adjacent and the hypotenuse. Well, to find angle A, I'd have to use the cosine, inverse cosine. Because if I'm given the adjacent and hypotenuse, to find the measure of angle A, I would have to use the inverse cosine of those two sides, which from our picture would be B over C. And say I knew the opposite and the adjacent, well, then I'd have to use inverse tangent to find angle A, because tangent is opposite over adjacent. So to find the measure of angle A, I would use the inverse tangent. Inverse tangent, that's a -1 of A over B. Okay, so be aware that this is how you find angle measures using inverse trig. So are you looking for side lengths or are you looking for angle measures? All right, very good. The next videos, maybe one or two, we're going to talk about these trig functions, trig ratios, and how we can use them to solve problems. So keep tuned in.